Hello, engineer from Peru and from all over the world. My name is Dr. Victor Fernandez, and in this case, we are conducting the program Chemical Engineering Today. Okay. In this opportunity, we will have two interviewers. Okay. In this case, will be Mr. Dr. Alan Murray, who is former Chief Engineer and Chief Safety Officer at the Canadian National Energy Board. His 45 years of work experience spans research, regulating, third-party assessment, design and development in steam plant, pipelines and offshore structure. He's founding chairman of the American Society of Mechanical Engineers. Well, Mr. Alan is a very well-known author and authority in transport and distribution pipelines. Here is as well engineer Abelardo Ortiz. Abelardo Ortiz has a lot of experience in energy plants, in transport and distribution pipelines. He will accompany in this opportunity to develop a very important thing for Peruvian. We are talking about natural gas transport and distribution pipelines. Please, in this moment, I will say thank you to Dr. Alan Murray to be here.
Thank you very much. My pleasure. Thanks,
Abelardo.
Thank you,
sir.
Thank you.
Engineer Ortiz, thank you for being here. Okay. First of all, I would like to talk a very important thing. In this case, the Engineer College has made a great effort in order to come with us, Mr. Alan Murray, in order to develop a course. The course is talking about the design and operation and integrity management of natural gas and liquid gas pipelines. This is more than 40 hours here they are developed here in Peru in the Engineer College. Naturally, we don't have this kind of course. I think that it's a good idea, a great effort from the group of chemical engineers from this organization. Okay, I would like to begin the interview asking Mr. Murray, what are the most important factors to be considered when we design natural gas transport pipeline?
I think I would say there are three areas: social, economic, and then technical, and they all have very special needs. Socially, we need to realize that pipelines are very efficient and very safe at transporting large amounts of hydrocarbons. The whole society needs to appreciate that, and you'll find that in parts of the world there's a lot of opposition currently to building new pipelines. I think it's because people don't understand the economic importance of pipelines and the fact that it can raise the standard of living for any particular country. Economically, I think it's an instrument or can be an instrument for government policy. If they want to open up parts of the country to development for research, not research and development, but for exploration and development. But economically, if you're going to build a pipeline, you have to be sure that you have enough reserves to be able to recover the total cost of your pipeline. And so that means that there's a lot of technical work involved in that, to do reservoir studies, to look at the demand picture and see how the both of those are going to be matched going forward maybe 25 or 30 years, because typically that's the length of time that we recover the cost of a major transmission pipeline. And then when we look at technical challenges, we have to be able to always operate safely, because that speaks to the social aspect as well, and we have to operate economically. So how do we design a pipeline that's both safe and economic? We have to think about using standards where they exist, because they've been around for 70, 80 years. They show that you can operate and build a pipeline safely, design it too, and they also have given us indications of areas where we need to develop new areas for work, where we need to have research and development going forward. And those would be, say for you in Peru, using higher strength steels, for example, where we can reduce the cost of the overall project. Most of these projects, the material costs are about 30% of the total cost, 35%. So if you can use a higher strength steel and reduce the amount of steel, you reduce the cost. But if you're going to use higher strength steel, you're going to be in a position where you should also use mechanized or semi-mechanized welding. Not too difficult to take your existing welding people and train them to using semi-automatic. And why would we do that? Because it's a factor of 3 and sometimes 4 times more efficient. And then we have to look at inspection techniques. And those are all playing into helping to keep the cost of a pipeline down. And then from design, we're going to find that you in Peru have some very unusual challenges. You're very unusual because you've got to deal with seismic activity, steep hillsides, floods. And if anything, we're seeing in the world that severe events are occurring more frequently, and they're even becoming more severe. So even if we rely on the existing standards, they applied to behaviour 30, 40, 50 years ago, and we maybe need to take a really good hard look at what has changed, and are we adequate, and are the standards adequate in being able to meet these challenges of keeping the costs down and keeping people safe.
Talking something about the new materials who are being developed for these kind of projects.
Well, it's interesting that every decade since 1950, every 10 years, the available highest strength steel has matched in thousands of pounds per square inch at specified minimum yield the actual year or decade that it was discovered. So X52 came about in 1950, X60 in 1960, X70 in 1970, and so on. And so now we're in the year 2015, and we actually have some pipe that's X120. Huge improvement in terms of the capacity of pipe. Now, there are not many projects in the world where we would want to use X100 or X120, but typically for you, X65, X70 pipe is a major step beyond using X52. And so our experience base of using X52, X70 pipe is very good. And that's important for people to realise that even if we change the steels that we use, you may not have used them, but they're in wide use elsewhere, and so people can feel confident about it. Okay. That answers your question, I hope.
Of course. We have more than 15 years involved in natural gas transport pipelines. Do you think that it's time to Peruvian researchers begin to be involved in our problems? That means we have tried to copy all the technical and advance in this field, but we have a special problem and we need a special solution.
For sure.
Do you need that?
Well, I think so. I think there's a lot of opportunity for you to specialize in geotechnical problems, because they're so unusual and you've had such a lot of experience. And that's an area where you could share or lead the world actually in terms of your experience. You have some parts in the southern provinces, in Ica for example, where you've got massive deserts and crossing massive deserts, and the movement of sand, it's just unbelievable, the type of problems that you have there that you're solving and working to solve. And other people in the Middle East, for example, who have a similar type of geography, they would be anxious to share that sort of stuff, you know. But even with your response to slopes under heavy rainstorms and so forth, again, I would say geotechnics is an area that you would be able to lead the world. And you can do that by maybe participating in international conferences or even hosting your own conferences here and inviting people. And so you start networking. And I mean, not start because you've been doing networking, as you know, because we have worked for a long time together. But I do think that it's an opportunity for Peruvians to have their name forward so that they're the people who are invited to international conferences, right? Rather than Peruvians inviting people from North America. Time to change that, you know, and you can do that.
Okay, thank you. Engineer Ortiz, perhaps do you have some question to Dr. Murray?
Yeah, I would like to ask you. You have been talking about the engineering, and there is another subject in the engineering, which is the standards and standard regulation, etc., that makes the something is feasible or not feasible. In that way of thinking. What is your experience, sir? We know that you have a lot of experience in many fields, in construction and regulator and so. And we would like to know if what are you feeling about the regulation and to regulate or deregulate is supposed to be there. It's healthy to have a balance in there, or what do you feel?
Well,
what is your feeling?
I think, Engineer Ortiz, that's a really good expression, having a balance, because the regulator has to protect the public, the public safety, but they also have a responsibility to operating companies. Companies have to be able to make a profit to exist, so there is that balancing that has to go on. Now, you will find that the standards generally over time have been written to be prescriptive. You will do this, you will do this, you will do this, and so forth. Now, over time, over 60, 70 years, we have gradually evolved, I think, to some better ways of doing things. But the standards themselves, the very word standard, implies everybody doing it the same way. And everybody should do it the same way if it's the same problem they're trying to solve. But if you're going to be working in a very unusual area that's not really covered by the standard, and there are lots of those, then you have to think about an alternative to the rigid approach that the standards would have, because it would prevent you from doing any of these new type of projects. And that's when you start moving toward light-handed regulation. Now, the regulator has to be very careful because they are responsible to the public, to the government. And so it might be that some of these new techniques are very complicated technically. Maybe more technical than the competency of the people in the regulators. Not just here in Peru, but throughout the world. And so if the regulator decides to move toward more light-handed or lesser regulation, they have to feel comfortable that what is being proposed by the applicant, by the pipeline company, is adequate and is safe. And to do that, I would encourage, and it has happened actually in Canada, that the regulator would engage a third party of technical experts who would be able to give a very insightful opinion on what's being proposed. And so the regulator could feel comfortable that this third party has examined everything that needs to do it. Yes. And that's the mechanism I would see for being able to balance strict regulation with light-handed regulation. The only way that light-handed regulation will work for a regulator right now, I think, is to have that external expertise. Yes. Because I don't think you have it inside the regulatory environment.
Okay, thank you very much. I think it is brought from you to us, from your experience here, and we appreciate that. And maybe just an additional question to refer to the same standards. In many standards we have seen, sometimes we have to be hesitating, is that the regulations are not clear enough as expected.
Yes.
As expected. So, and that begins different opinions as what should be, what should read in there. And do you have an answer for that? Why is that?
Well, when you look at, say, let's pick one of the American standards, but it would be typical of most. All that we actually get guidance on is designing for internal pressure and temperature. Actually gives you an equation for these things.
Right.
But then it says, you will consider. And then it gives you a long list of things that you need to think about.
Right.
Well, we know we need to think about them, but we would like some help in how we should think about them. Well, so the standards are very silent in those areas. And that means then that the regulator in particular who are relying on the standards,
Yes.
well, there's nothing there.
Yes,
And so
exactly.
you're then looking for external organizations who can help. And one of the things that for pipelines is very helpful is the American Lifelines Alliance. They publish free on the, you get it on the internet, but it's very, and it's part of the American Society of Civil Engineers, so it has been peer reviewed. It's not, you've got to be careful about Googling things, but this is actually a peer-reviewed document, and it will describe for you how you handle accidental loads, how you handle earthquakes, things that you're supposed to consider without the standards telling you how to do it. So I would get some comfort from the fact that there are other publications there. The Pipeline Research Council International is another area. And even the United States government on the PHMSA, phmsa.dot.gov is a website that's got a lot of information about research and designs that people have put forward that are outside of the normal standard.
Okay.
But that's where you go and find out what did they say and what are they considering, because you can go outside the standard. In the United States, you have to ask for special permission. It's called a special permit. And there are examples. You can go onto the internet under PHMSA and find it. Give me an example, for example, of where we've gone beyond the standard, gone from 72% SMWS to 80%. What are the sorts of things you need to consider? And there it is for you in black and white. So the regulator has stopped short of saying do this, do this, do this, but they've also created a library or a series of documents that would be helpful to you in considering.
Yes,
So there is information there. You just have to look hard for it. You know?
most helpful. Most
You're
helpful.
welcome.
And I appreciate.
You're welcome.
Thank you, sir.
Okay.
So,
Engineers from Peru, from all over the world. This is your program, Chemical Engineering Today. I am Dr. Victor Fernandez, and we are talking about natural gas transport and distribution pipeline. We will come back in some minutes. Hello, engineers from Peru and from all over the world. This is your program, Chemical Engineering Today. I am Dr. Victor Fernandez, and here is interviewing Dr. Alan Murray, and we are talking about natural gas transport and distribution pipelines. In this case, we are talking about distribution. Please, Dr. Murray, can you tell us how can Peruvian engineer be involved in distribution, in natural gas distribution pipelines? That means what must be depending of the type of engineer can do in order to be involved in the design, in the operation and the construction perhaps? What's your opinion?
Well, construction for distribution lines are very, very different from transmission. So a person would find that the pipe, the polythene pipe, is pulled in off a reel, it's ploughed into the ground. So someone with a good civil engineering background would really appreciate working like that. There's always the economics of connecting new people to the system. How much is it going to cost? Where should you locate it? And we're back to the same problem with public safety. We operate distribution lines at a much lower stress level, as you know, than a transmission line. And we do that because we know that in a built-up area where distribution lines occur, it's more likely that someone will strike the line or do damage to the line. So a young engineer who's aware of dealing with the public, informing the public, because I don't think people deliberately add a pipeline. They want to know it's there. And so I think for a young person going into a distribution, they have to be as much a person that can do social interaction as they are engineering. The engineering is not too difficult, but dealing with people can be important. And so I think I would say look for people that have good social skills to develop it. And that's where I start. But people with a background in economics and techno-economics would obviously benefit going into distribution. And some of the issues would still be the joining of pieces of piping, how we do that efficiently. And the very important part would be the integrity management of distribution, because it's quite different from transmission. You can't peg the line, so you have to wonder what's the condition of the line. And so I would say a young person coming into distribution, focusing on integrity would be a great thing.
Okay.
Okay. Please, can you give us some comments about third-party damage?
Well, it's the most, in terms of the United States, it's the largest source of damage to a pipe. It's like 38%. Now, we could call it third party or we could call it external interference, because sometimes companies hit their own pipelines as first party. And the reason they do that is they don't have really good as-built drawings. They failed in locating their pipe properly. So not only are other people hitting their line, but they can't hit their own line, right? So I'd say that the solution for that is two parts. One, better signage and raising awareness. And secondly, you start thinking about maybe burying the pipe a little bit deeper so that it reduces the risk of someone hitting a pipe, right? But it's the major source. I think it's about, in the United States, it's 40% of all accidents are caused by external interference.
Yes, sir.
And that's frightening.
Yes, it's frightening.
Okay. How can we be prepared as a society in order to face this problem?
Of
Because it's
damage.
not only from third-party damage. It's not only engineers are concerned. I think that all the society in Peru must be work in this.
Well, if you look at, say, your situation here with gas coming to the city gate on the south side of Lima and then progressing through the city to Callao, well, at some point that is it's a major, it's a distribution system, but it's still a large diameter pipe.
Yes.
And then from that we've got branches coming off, and then branches coming off that. So those small pipes, again, coming to people's houses or shops or whatever, you have to think about awareness for that and how they become aware that there's a gas pipeline there. And it's amazing, even if you ask people who cook with gas, do you think there's a gas pipeline here? And they say no. And then you think, well, where does the gas come from that you're cooking with? Oh, never thought of it. So most people never think. But if you look at the bigger problem, and that is when these, and it will happen here in Lima eventually, when these pipes were first put in place, oftentimes they were open fields, there was plenty of room around them, but now you find in many, many metropolitan areas throughout the world that people are ever closer to the pipeline. And so it's probably from an act of public policy a good thing for the government to think about transportation utility corridors, a corridor that is dedicated to all the electrical power lines, where the railways go, where the pipelines go, and the public are completely segregated. Now that would be the very high pressure pipeline system. Obviously you have to come off that to get into people's homes or businesses, but that's a method that's being used in Sao Paulo, in Edmonton and Calgary and in Pittsburgh, Minneapolis and Pittsburgh, to make things safe. So they put these pipes, larger diameter pipes, that were built a long time ago, and they're leaving them in place but reducing the pressure, and then building a new ring main further out in a complete transportation corridor that's dedicated And so you're limiting the number of people that can come close to your pipe, and therefore you limit the amount of damage that you can do.
You are an authority in natural gas pipelines, and you have been here in Peru many times.
Yes.
Can you give us some advice in order to continue develop our grids, our pipeline, our distribution system?
Well, I think you're undergoing, every 5 years or 4 years you have an election, so you've got changes of government. Within the regulator, I think you can only be, a 5-year term or something. So you're looking for some stability in the framework. People who are investing want to look at Peru or anywhere else as a safe place to invest. So if they feel that there's stability from the government, then they're willing to engage in inward investment here. And that's where I'd start by saying, where are you with, Kuczynski as your president, and setting up an economic environment that's helpful to foreign companies to come. And so bringing in foreign capital would be a good thing for Peru. I think the people themselves, and where you advance, first of all, you're technically smart. You're very, very capable. You understand the basics of, the engineering here is as good as the engineering anywhere else, so that's not the issue. So it's giving people the opportunity. And so that means thinking about where will development happen. And almost certainly that's a combination of private enterprise with some sort of direction from the government in terms of tariffs and maybe making it cheaper for people to pipe from a particular area that's underserved right now. So there's economic incentives that they could do, all of which would help the engineering fraternity here to focus and feel, I can have a lifetime of work in this. If you're a young person at 21, 22, and you think, could I work in this business for 40 years?
Yes.
Well, you have to think, is there going to be a pipeline in 40 years? And you look around and say, well, why not? Mm-hmm. But I think the government and business can work together to try to create a good feeling for young people that there's a future in this business. Mm-hmm. And not just a future, but a really good future. I wish I was 21 again, Victor. I could come here. I'm very happily married to an Irish girl, but I consider marrying a Peruvian. I consider it. Okay. Just like the standard. I would consider like the standard. That's like the standard.
Okay, Mr. Alan, this topic is very, very interesting, and we would like to have continue working many hours, but time is time, and we need to thinking about this topic. I have the last question. Please give us some consideration, conclusion, advice for Peruvian people, for Peruvian engineers, for Peruvian chemical engineers who are seeing in this moment.
And do it in a few words, not many, many words like that. Well, I think the future's bright. You have to believe in the future. Your schooling is excellent. It's preparing you for a good career in a wonderful profession. And I think chemical engineers are a natural fit for pipelines.
Yes, sir.
They really are. And so for hydraulics and for the metallurgy and so forth, really good fit. So I would encourage them to, look for opportunity within this business. It's a great business.
Yeah.
I've been very lucky in my life. It's a wonder. You meet wonderful people.
Yeah. Thank you, sir. Thank you, sir.
All pipeline people.
Okay.
Dr. Alan, thank you very much.
Thanks,
it was a pleasure.
My pleasure. Thank you very much.
Thank you, sir.
Really good.
Engineer Ortiz, thank you very much. Thank you very much. We will try to give us always this kind of interview with an authority, with a well-known engineer in Peru. See you again. This is your program, Chemical Engineering Today. I am Dr. Victor Fernandez. Thank you very much.